All right, 7.5, exponential and logarithmic equations. So remember, an exponential equation is pretty much just an equation that contains a variable as the exponent. So if you notice, like number 1 and number 2, there are variables in the exponents. So it's a logarithmic equation, or an exponential equation. So two main ways to solve these. When you guys are doing them, these are pretty much going to be the start to most all of them. If you can write them so that the bases are the same, it's usually faster. So for instance, if you look at number 1, you have 2 and you have 8, which 8 can be written as a 2 power, 2 to the third. So if you can make that move, it'll probably be a little faster. But usually, you can also just take the log of both sides. So that's going to be what we're going to be doing probably most of the time, because not all of them are friendly enough to be able to get the same base. Some other things that you're going to need. So remember that you have the rules of the logs or the properties. So I know we had the product property, we had the quotient property, we had the power property, which I used a lot here in this lesson, inverses maybe, and change of base. So these were the 5 properties from 7.4 that you might want to brush up on, make sure you know how to use. The other thing that people seem to struggle a little bit with in class is when you're in doubt and you're kind of stuck and you don't know where to go, rewrite it from log to exponential form. A lot of times that's going to help you out. It's going to allow you to solve the problem. So let's jump right in here. Let's just get after it. Starting with number 1 and number 2. The first one, I'm going to rewrite these bases. So I'm going to go 8. I'm going to just represent as 2 to the third power. So that's 8 to the x. And 2 to the x plus 6. And then remember that back in the day when we raised powers to powers, you multiply. So this is really going to be 2 to the 3 times x. And this is 2 to the x plus 6. And as long as they have the same base, then the powers have to be equal to each other. 2 to the something, if it equals 2 to the something, these guys have to be equal to each other. So I'm just going to go right into just normal algebra here. Subtract x from both sides, divide by 2, and I get an answer of x equals 3. Over here to number 2, I don't think that I can rewrite 200 with a base of 5. I think it just blows from 125 to 625. So I'm not going to be able to do my bases. So what I'm going to do here is I'm going to just take the log of both sides. I'm going to do the log of 5x minus 2. I'm going to do log of 200. And I'm going to use the power property that when I have this exponent up top, I'm going to yank this thing out and bring it to the front. All right. So this is the power property. And I yank that out front, and I'm going to get x take away 2 times log base 5 equals log base 200. Remember, those are just decimals. There's just some number. So to get x by itself, I'm going to divide by that log of 5. I'm going to try to isolate that x expression there. Log base 5. And here's where I'll probably go to my calculator. And let's just figure out what that log of 200 over log of 5 is. And it is 3.292, roughly, if you cut it off somewhere. And then I'm going to add 2 to both sides. Add 2 to both sides. And I will get x equals 5.292. Now the nice thing is, if you want to know if you did it right, you can always take that answer, take this and plug it in for x, and then work it out and see if it actually comes out to be 200, or really close to it, because you rounded it. It may not be 200 perfectly. All right, next problem. 7 to the negative x equals 21. I can't write 7 and 21 with the same base. So we're just going to do the log of both sides. And I'm going to do the same thing as before. I'm going to use that property where I pull this negative x in the front. So I'll pull the negative x in the front. U gone now. And I'm going to divide by log 7. Divide by log 7. Cancels out. And log 21 divided by log 7, I got to be 1.565. And multiply both sides by -1, or just change the signs. And I believe that would be our value for x. All right, going over to number 4. Again, I can't use 2 and 15. I can't find a common base there. So let's log both sides. As you get faster, you could probably skip this step because I know I'm going to pull that 3x out to the front. So I could have probably just wrote 3x times log 2 and not even put that there. So I could have kind of took the log of both sides and used the power property to yank it out front. Let's get that x term isolated. So let's divide by log 2. Divide by log 2. And I get 3x equals, I put that in my calculator, log 15 divided by log 2. And I got 3.97. No, 3.907. Divide by 3, divide by 3. And we get x is approximately 1.302. All right, so still just taking the logs of both sides. Well, I get down to number 5, and these actually are written with logs in them. Like they already have logs in them. So I'm either going to do one, I'm not going to take the log of both sides, but I'm either going to rewrite it in exponential form, or I'm going to use some of the properties. So on this one, I think I could just use exponential form. So putting this in exponential form, my base is 3, my power is 2, and it equals this thing. So then it becomes a pretty easy algebra problem. So x just equals 14. All right, go over to number 6. This has 2 logs in it. I'd like to whittle that down to 1 log. So I'm going to use my properties. And I remember that when you do a log minus a log, you can divide them. So one of our rules, this was the quotient property. And the quotient property basically says that if you have, the log of A minus the log of B, well, that's equal to the log of A divided by B, the first thing divided by the second thing. So I'm going to kind of use that property here. So I'm going to simplify this down to 1 log. And I'm going to do the first term divided by the second chunk equals 1. I believe I can divide that out. So I can get log of 15x equals 1. And now you might kind of be stuck. And you might be like, man, what can I do? Well, remember, when there's no base, it's really base 10. So now I should be able to rewrite this in exponential form. 10 to the first power, which is 10, is 15x. Divide, divide. And we get x equals 2/3. So I kind of used the quotient property, and then I used exponential form right down here to finally close the deal, finally solve it. All right, number 7. This one I see 2 different logs, and I see that they're added together. So this is the product property. Product property, basically, it's the same as that quotient property, but we can multiply the 2 things. I do notice something different, though. I have the log of 8, but then I have this 3 here that I really don't like. I'd rather have it log of something plus log of something. So I'm going to do the opposite of the power property. Basically says, hey, if you want, if it's helpful, put the 3 up here as the exponent and get rid of it from there. So I'm going to do that first. So I'm going to have 3 equals log of 8 plus the log of x to the 3rd. I like that because now it's pretty clean. I have my A thing, I have my B thing, and when you add 2 logs, I can multiply those together. So I'm going to get 3 equals a single log of 8x to the third. Again, I feel like I'm stuck, so let's just put a 10 there. And this one, my little circle thing doesn't really work here because the 3's on the left side, but I can do base 10 to the third power equals 8x to the third. And both of those are perfect cubes. So I could multiply the 10 out 3 times and go down that road. But I'm going to just do the cube root of both sides, because the cube root of 10 is just, or 10 to the third is just 10. The cube root of 8 is 2, and the cube root of x to the third is x. So 10 equals 2x, divide, divide. Looks like x equals 5. And you could try that in your calculator. You could substitute 5 in that original equation for x and see what shakes out. All right, next one, number 8. So I see a subtraction. So in my mind, I'm thinking, okay, I'm going to be doing division here. And I don't like that 2 in the front, so I'm going to move that 2 up here and get rid of it. So that was a power property. And now I can get a single log of x squared divided by 4 equals 0. Go ahead and put it in exponential form. 10 to the 0 power equals x squared over 4. Or remember, 10 to the 0 power is just 1. And multiply both sides by 4. And I get x squared equals 4. Now, to solve this, I take the square root of both sides. And remember, when you take the square root of 4, you get 2 answers. You're going to get positive 4, and you're also going to get negative 4. Now, you got to be really careful here, though. So this is one you want to kind of pay very close attention to. Because when I go back to the original equation, if I try to plug these in, if I try to put log negative 4, that right there is going to give me an error. You know, it's undefined. You cannot find the log of a negative number. It's impossible. Because negative exponents just get you closer and closer to 0, but they don't cross. So even though I got 2 solutions, one of them did not work. I believe they call those extraneous solutions. But so the answer is just x equals 4. So be careful on the quadratic ones. All right, next one. How do I want to do this? I got options here, man. I think I'm just going to go to exponential form. Why not? 4 to the 7th power equals x squared. 4 to the 7th power is boom, 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 boom. 16,384. Big O number. Take the square root. Take the square root. X equals positive or negative. Looks like 128. Now this one's a little tricky because when I plug negative 128 in, I think that it'll work, because if I punch in log base 4, and then I put my negative 128 in here and square it, it's going to be a positive number. So I think they both work, but I'm going to have to double check a little bit on that negative one. I could be wrong on a technicality, but we'll see. All right, next one, I see addition, so I'm thinking multiply. So I'm going to single log it, and it ends up being just x times this, which is x squared plus 9x. X times x plus 9 is x squared plus 9x. Base 10, exponential form, 10 to the first, which is 10, equals this. And this is a quadratic. So I can't get x by itself. So what I want to do is I want to set it equal to 0. That's how you always solve quadratics. Set them equal to 0. And then I got 2 options. I'm going to always try to factor first. If not, I got to use the quadratic formula, which is way bigger than what I want to if I don't have to. So let's see what we can do here. Can we get two numbers times together to make -10, add together to make 9? I think we can. I think that combination, whoa, needs to be a 1 there. Check that. I think that'll do it. Now those are only factors though. We need to get zeros. So x is either -10 or x is 1. And then I got to be like, well, can this work? And right there, we have a problem. I can't do log of -10. So you're out. You're the real answer. That one was pretty clear cut. All right, number 11. You know, a couple different routes you could go. I could see, is there a 2 to the something that equals 1024? Like I could play around with that and try to get the answer and write it as the same base. Could do that if I wanted to. I don't really feel like doing that right now, so I'm just going to go log of both sides. And I'm going to yank that 2x out to the front. And isolate the x part. So divide both sides by log of 2. I'm going to get 2x equals, it's like 10. And divide. And I get x equals 5. I think if you were able to write the base, I think you could rewrite this as 2 to the 10th power. If you could figure that out, it would be much faster because now you can just go 2x equals 10. So it is faster if you can figure it out, but sometimes it might take you a while to figure that out. All right, the top one. Well, I see a subtraction of 2 logs, so I know I can divide those two. And this side's just log of 75. So if log of one thing equals log of another, the two things have to be equal. And times both sides by 2. That one was pretty quick and painless. All right. You'll notice the last two are the same because I wanted to show kind of 2 different ways to do it. So on the right, I'm going to rewrite the base both as 2. So I'm going to do 2 to the x equals, well, 4 is really 2 squared. And then that's to the x minus 1. And when you raise the power to a power, you multiply. So I need to multiply this 2 times all of that. So this is really 2 to the 2x minus 2 when I distribute it through there. And now I can just simply make these two be equal to each other since I have the same base. That'd be negative x equals negative 2, or positive x is positive 2. Now, the other way is maybe you didn't want to rewrite the base thing. So I'm going to do the log of both sides. I'm going to do the product property. So I'm going to pull, or the power property, I'm going to pull that x out front. All right, well, I have, let me see, I have an x over there on the left. So maybe I'm going to divide this side by log of 2. Divide this side by log of 2. That goes away. So then I get x equals log of 4 divided by log of 2. Let's just see what that is. Log 4 divided by log 2 is just 2. And multiply that out. That's 2x minus 2. And I kind of ended up being at the same position right there. So a little more work to go that way. I definitely prefer the one on the left if you can see it. All right, so hopefully that's 14 examples showing you different strategies, using the properties, taking log of both sides, rewriting bases. Hopefully you got some weapons now to attack the 7.5 practice. See you.